Okay, let's start. So I'll try to take you out of your lunch coma. Let's see if I'm successful. So this is the first of a two-part talk. This one is about the anatomy of software supply chain attacks from the attacker perspective. The second one will be after the coffee break, so you don't need me to wake you then. It's focused about the AI security role of supply chain. So let's get going. My name is Erez. I'm the VP of Security Research at Checkmarx. Another thing I do is run several projects and committees at OWASP, and I'm the founder of the AppSec Village at DEF CON, if you're familiar. If not, come talk to me, it's really fun. My superpower actually is the fact that I am exposed to a lot of mistakes, and we see a lot of mistakes out there. When we're talking about supply chain, it's usually well known. This is something that exists since the era of, well, supply. So what's up with software supply chain? Why is it so different? What happened there? Where did we lose control over our supply chain? And for this, I want to give an example from an industry that is very much traditional these days, the automobile industry. I know nothing about cars, so my examples are going to be completely theoretical. But let's imagine that I'm running a car factory, okay? Let's say I'm creating the chassis myself, but I bring the engine from, I don't know, somewhere in Europe, the windshields from Japan, the tires from I don't know where. But this is how I build things, and this is my supply chain. One morning, I walk in the street, and there's a nice guy coming up to me and tells me, wait, you're running a car factory, right? And I say, yes, of course. And he says, cool, take this. This is a braking system I invented. It's really good, and it's free. And I tell him, really? It's really good? And he says, yeah, of course. It has 5,000 stars or likes in brakingsystem.com. Yeah, I see some of you smile, but this is where our software supply chain is at the moment. Okay, we have addicted to the trust in this system that does not exist in any other supply chain that needs certifications and really clear understanding of where things come from. And this is something that everyone is noticing. How many of you know Salsa by name? Okay. This is actually getting better with each talk. So several organizations, serious ones, decided to create a supply chain levels of software artifacts. This is kind of to understand where are the problems hiding in software supply chain. And this is a very simplified way of looking at software supply chain. Starts from development, through source, build, package to the consumer, and we have all the dependencies in the middle. But something very funny happened, because when they decided to mark all the places that can go wrong, it was everywhere. So basically, every single step of the way could be a source of a point of entry for an attacker. Now, this talk is not going to be about this part, about the mainstream part, about the source, build, and package, although this could be the third part, probably, of this talk. But this is because we have more control over it. This is something that we do, that we create, that we package, that we send, that we build. This is something that, if we're paying attention, we can really lower the risk. We're going to focus on dependencies, because dependencies is the real Pandora's box. So if I gave this talk, I don't know, 15 or 10 years ago, in some organizations, maybe even 5, I would show this. And I actually heard 10 years ago CISOs and development organizations telling me, okay, so we won't use software, open source software, no problem. We don't need these packages, we'll do it ourselves. And then they were thinking about what is the good thing of using open source and avoiding open source. This is not really relevant anymore. Okay, this train has left the station a long, long time ago. Everybody uses open source. Developers want to deliver fast, and the dependencies are piling up. Now, the dependencies of the dependencies are usually the surprising thing, because when we show to developers, by the way, they know that. but there is a difference between knowing and being constantly aware of things. So when we talk to developers as security people or attackers using that, this is what developers are asking for, right? This is me, this is the package I want. I want nothing else. This is what I want. The truth is that we are getting some things that we did not explicitly ask for. And the true truth is that it looks more something like that, or way more complex usually. So when I created it, just took a random package, CNCJS, I don't even remember why. When you install it, just one package, it has 811 dependent packages, okay? From 611 different contributors. This is quite crazy, okay? This is not a thing that any developer or any organization, no matter what size and no matter the maturity, can actually follow and handle. We are in an open source jungle at the moment, but we are also closing our eyes, and we still trust it somehow. I hear a lot of reason to trust it. We naturally tend to trust open source because, and I wrote it here, it's open for everyone to look at, right? You hear that a lot probably, maybe you even say that. If there's an issue, someone will notice. There are scoring mechanisms to star and rate. Remember, 5,000 for a braking system, and it gives a trustworthy feeling. Let's switch. Let's talk about when a good package goes bad. This is Faisal. Faisal is a nice guy. Faisal lives in Indonesia, and he is the main maintainer, if not the only maintainer, of a package called UA Parser. Okay, UA Parser is a very, very popular package. Would you use it? Show of hands. Who would use this package? Let me give you some info, okay? This package is maintained for 10 years. Would you use it? I would. Okay. It has, at the point of creating this, 10 million weekly downloads. Who would use that? Okay. It's used by millions, including Facebook. Who would use that package? Okay, all the rest of you are liars. You would all use that, your developers use it, and honestly, you're probably using it as we speak. This is a very important part of parsing client-side in JavaScript. And everything was fine and well. In parallel, not related at all, in the darknet, Russian underground, in October 5th, 21, someone wrote, I'm without my eyeglasses, so I sell a development account on NPM, more than 7 million installations every week, there is no 2FA on the account. Cool. That's happening all the time. We see these kind of messages all the time, things are for sale, and a couple of weeks later, Faisal say, guys, I'm sorry, I think I got hacked, someone is pushing something, it's not me. Okay, this is the package that we all use. The attacker used his account, Faisal's account, and pushed 3 different versions just to make sure that we're not missing it in any upgrade that we do. And this actually included a payload that downloaded some malicious code from somewhere and started to run a crypto miner, and also an ability to take over your machine. 2 weeks later, in November 4th, 2 other NPM packages with 22, with a combined number of 22 million weekly downloads, COA and RC, also got the exact same malicious code. Okay, they are not related to Faisal in any way, and this means that these attackers found a way. This is what they do. They are looking for accounts with no 2FA. They're looking for accounts that has good status, that are popular and are easy to take over. And this is something we see all the time. Okay, this is when good packages turn bad with no reason, with no apparent reason. Another example. This is Brandon. Brandon is also a cool guy. Brandon rides electric motorcycles because he wants to promote the use of clean energy. Also, Brandon gives back to the community. He maintains 41 packages. This is only NPM. He also has packages on PyPy and Maven for Java. One of his most popular packages is Node IPC. This is something that is very important for inter-process communications between different platforms. I see some people nodding. I guess you know what it means. Let's do the game again. Would you use that package? Yeah, let's make it quicker this time. 1 million weekly downloads, maintained for more than 8 years. Would you use it? Yes, you would. And there's no reason not to. But suddenly, March 7th, 2022, Brandon added a new functionality. It was actually only a one line of code, heavily obfuscated when you look at that. Just a tiny bit of reverse engineering brought us this code with 3 different functionalities. One functionality checks your IP geolocation. Where is your machine located? Why is Brandon interested in that? If your machine is located in Russia or Belarus, this is what happens. Delete, 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 delete. Your system is deleted. Your backups are deleted. Everything from the root level is deleted. Obviously, Brandon decided to take sides in the Russian-Ukrainian war, and this is what he did. He also wrote, this is all public, documented, licensed, and open sourced, and he called it protestware. This is the first time that this word was invented. And for someone who gave him some criticism, he answered, you downloaded my software for free, so I'm allowed to wipe your computer. Apparently it's documented, so yeah, you're allowed to. This is an interesting way of a package gone wrong, because this is actually the maintainer that goes the wrong way, okay? By the way, would you still use that package if you're not from Russia or Ukraine or Belarus? Probably not, right? Something is not really right here. Something does not feel right. Actually, this package was reported and removed. And then we got some very funny remarks. Brandon, that's abuse of power. Don't become what you hate. Thank you for teaching me not to take handouts and code everything myself or try dying. Again, we're back 10, 15 years. Or the one that I had some trouble understanding because I'm not American. This takes Let's Go Brandon to a whole other level. But eventually I got it. So you would not use that package. What about these other projects? Because this package was removed. What about the other 40 projects by Brandon? They were not removed. They are still there. They're still running the infrastructure of the internet. And even if we remove them, what about what he did in Python and Maven? Right? This is something that we don't want to think about. Now you have to. So a good reputation is hard won. Easily lost, but it's also lost in the crowd of open source. And by the way, we're going to talk about, is it really hard won? Let's go to some more malicious people. So attackers are evolving. They not only buy or take over packages now, they are actually starting factories to create those. Red Lily is an organization that we first uncovered in November 2021. They managed to publish 1,500 malicious packages in 1 month. This is something that back then was beyond what we can analyze. Now we do it easily. They managed to bypass CAPTCHA and create accounts automatically on several platforms. They created set up custom exfiltration infrastructure to be able to steal information and send it out. And actually, they were hiding some payloads in README file. Very, very sophisticated, very sophisticated setup that showed us that they are really serious. It's like a company, working a company. Their payloads kept improving. It was a real cat and mouse for us. Code obfuscation and scanner evasive code, exfiltration infrastructure, as I said, they actually created places in the internet to be able to send information to And they hid all the payloads. They created disposable domains. They were like setting them up, running them, disposing them in days and even hours sometimes. And this is the cat and mouse game that I mentioned. Actually, eventually they got tired of us and they started to communicate with us in the titles of the packages, which was hilarious. It started with, he is not what you see, and then they called it hello boy, and then no so awesome, and then we got the last one that I will not say on stage, but they became really, really angry. So why did people download and use these packages of Red Lily? We talked about reputation, right? We're looking at the reputation, we're looking at the stars, we're looking at the at how long it is on. So why would people use them? Sometimes you can piggyback on reputation of others. Okay, this is what we do with attacks that are called typo squatting. Typo squatting is for when you use a name of a package that either has a typo or just sounds similar or looks similar. For example, this is a package that is called, two packages here. One is called Pumpy, one is called Pumpy.io. And by the way, the website of the documentation is at pumpy.io. Which one would you use? We'll get back to that in a second. But basically, both packages have the same code in them. So if you use any one of them, everything functions perfectly. No tests are broken, nothing looks suspicious. You don't even have a way to know if you're good or not. If you look closely, you'll see that Pumpy.io has just a tiny more, a strange tiny dependency called red apti. And when you look at it, you see that it runs a very weird URL. Can you see what's weird in the URL? It's basically reversed. Okay, that's it. And the only reason it's reversed is just to not look suspicious immediately. But when you look at it, you can find that it pulls information and send environment, all the environment details from your system just to a public bucket. So this is malicious code in a sub-dependency. Actually, it was like 3 layers deep in Pumpy.io. And let's go back to that. How would you know which one is the fake one? You look at the stars and forks, and you see that both of them has the exact same numbers, okay? Both of them with more than 3,000 stars. And the same forks, everything looks exactly the same. How can that be? So what we found is something called starjacking. Starjacking was an attack that was uncovered by Checkmarx back then. And to show how easy it is, we created a tool that obviously is not open to the public. This is an internal tool we used to fake malicious packages. All we had to do in this tool is to randomize a username on PyPy. This is the package manager of Python. It would create a username. We would choose a name of the package and the version. Remember, you want the version to be higher in case you are faking something similar. And then we go to GitHub and we look for a trending package. Okay, in this case, it's just a bunch of ebooks of The Economic. That's it. The reason we want it is because we are piggybacking on the fame of this GitHub repo. This GitHub repo has more than 9,000 stars, and what we're saying here is that we are part of that repo. Yeah, PyPy would let you, we'll ask you and we'll believe you. So we just do that. We put it in. The next part is just to put a payload. In this case, it's just sending all your secrets to a public place. And that's it. This is all it took from us. And while developing that, we understood how Red Lily managed to create such an efficient factory back then. Again, you can see this is our malicious package. It's not really malicious. With the amount of stars and forks of a GitHub repo that is not even relevant, that's it. So when we found that out, we talked to PyPy. Basically, it took them about 2 years to fix it. So this is something that happened. I'm happy to say it happened 3 or 4 months ago. This is not possible anymore. In other package managers, it's still possible. So, the problem is still there. And we did not try to bypass it because we are afraid we'll succeed. So we do not know. From the attacker point of view, this is the user running it, just installing it, and that's it. Immediately the attacker has access to all the secrets. Again, not very hard. Why is that easy? Why is it so easy? I already gave a lot of clues. So there's no vetting of metadata that developers rely on, okay? And we really rely on that. This is something we do. It's all the information that is not vetted is very important. The related Git repository, as I said, fixed in PyPy, but not in others. The website URL. I can say it's part of, I don't know, google.com, Amazon, whatever. No one checks. Description, I can write whatever I want in the description. Name. Again, we opened several packages with the name AWS something. No red light, no red flags, nothing. Everything worked fine. So it's really hard to know who's who, and we don't expect our developers to be, detectives. Also, things we mentioned before, not all maintainers enable 2FA. This should be a really red flag. I mean, if something is not 2FA, don't use it, really, if possible. And expired domains. Again, this is something that attackers love to check for and go for and take them. And the last thing is actually the takeover that I like the most. It's basically maintainers that getting busy, don't care anymore, don't want anymore, just dropping them a line. I see you're quite busy and not maintaining this project anymore. Can I manage it from now on? The answer would usually be yes, you are now a maintainer, because people don't have time and it's a really thankless work. Another problem we have is the auto-update by design. Okay, we talked about it earlier, about the versions. You ask for a version 6.1.2, but if there is something suddenly that is more updated, you will get that. Again, we can discuss if it's good or bad, and to talk about vulnerabilities that you manage to fix. But we're talking about malicious attackers at the moment, and this is one of the issues, right? This is something we've seen in Faisal before, and this is the discussion I mentioned about do we want to slow update and risk vulnerabilities, or do we want to fast update and talk about supply chain risks. And the last thing is really not us to blame. This is the industry in general, and something that my group is trying to tackle every day. But this is the time to detection and time to remove. Attackers are relying on that. And honestly, apparently, they have a really easy time at the moment with that. This is research, not new already, 2-3 years ago, but the numbers did not change significantly. Research from University of Bonn says it takes about 200 days to detect malicious packages. This is crazy time. But if you think this is worse, this is the other part of it is the removal of it. So we're talking about mean time to detect, about 200 days. What about the mean time to remove? You want to guess? You can guess, because this is really not something we manage to quantify. It could be weeks, very rare, and it could be years, okay? Sometimes it's getting better, but this is really not what we expect from the package managers. In some events, they actually trust us specifically, so when we report something, they are much quicker, but assuming that we're not covering everything all the time, the industry is not in a good enough situation. So we need better transparency of reported packages to improve the removal time. And basically also we need a way to share information. So what do? First of all, we need to understand that vulnerabilities are not the same as malicious packages, okay? Vulnerabilities are a mistake. This is something that someone did not know how to do or did not care how to do them. When we're talking about malicious packages, we're talking about attackers. We're not talking about the code. We're talking about people who are malicious. There is no risk management around it. You need to have zero tolerance. This is literally getting someone into your code base in the first time you run the package. Okay, it's not a vulnerability that might be dangerous. It has a CVSS number. You need to do it in a week or 2 or 3 or whatever your SLA is. You are never okay having malicious open source code. This is something that, again, we keep ignoring, because if I ask all of you has some sort of tool in your, that you're using, like SCA or something like that, but honestly, no one is looking at malicious packages. And we need to share information. Instead of removing packages that are reported, like we talked about Brandon, package removed, basically they removed this package, but they cleaned his name as well, because you have no way to understand what happened and to follow up. So we need the industry to audit and share evidence. We need findings of malicious packages, package samples, full metadata, users, everything like that. We collect everything we find, and we share the information with other researchers. This is something that needs to happen on an industry level. My dream is to have a central repository sharing this information for everyone. If someone wants to start that and call me in, please do. In general, we need better standards, okay? Attackers love that things that are really weird and clunky. We need universal IDs. This is the first thing we need. Currently, when we have the same incident of malicious incident, it doesn't have a CVE because it's not a vulnerability, again. So a specific incident, this is something that is reported both in Checkmarx, Snyk, Sonotype, and GitHub. You can see that each one of those have a completely different number, way of looking at things. It doesn't even matter who found it. The others will just give it a different name. And really, we're in this together. We work hard to share knowledge. The lack of awareness and visibility by security teams is our biggest enemy at the moment. And that's it. Thank you very much. I hope it was an interesting glimpse into the thought process. Questions? Do I have time for questions? I don't have a watch, so I guess I do.
The example, where you have this .io and then you don't have the package example that you mentioned.
I need you to repeat. You want to see it again?
Yeah. Just this slide.
Let's do it the hard way.
Yeah, this one. Yeah. So how do you do this right?
You literally need to analyze the code, or check, try and understand what people used so far. Try to understand when this package was uploaded. There is a date somewhere hidden. You need to look at it, but don't make mistakes, I guess. Okay. So currently, specifically in Python, this is solved. So you will not see that again, the same number of stars and everything. Yeah. And by the way, no developer would be expected to go so deep in that. They read documentation of pump.io, pip install pump.io, thank you very much. All the tests work well, production runs smoothly. that's it.
Have you tried this in other programming languages like Ruby or Java?
So yeah, it worked in several, I think it worked in JavaScript in a way and Maven. I need to check my memory. Yes, please.
Any other lesser known techniques that you just didn't have time to include in the presentation?
Yes. Yes.
First one that comes to mind.
Okay, so there was something that we found also called repo jacking. Repo jacking is something that maintainers who decided to delete their package, the name was just released back to the I don't know how to call it, to the void. So attackers actually were finding ways to look for those specifically and register them and started to use them. By the way, this is not something new. We've seen that in the past in all domains. We've seen that in S3 buckets that people release. We just need to be more alert. But yeah, there are many tiny things like that, and the fact that we're thinking as attackers makes us very make us find interesting ways to solve problems and solve security mechanisms. So we find new things every day. We report them. Most of them are being fixed. Some are not. This is what we do. Yes, please. Can you repeat the last sentence? You're speaking very softly.
The goal there is surely can't be just to have millions of potential typos expected. What do you think? What do you have any idea what their goal might have been? Maybe some millions of malicious packages.
So there are millions of malicious packages. Only in our database, from the last couple of years, we have more than 300,000. Okay, most of them are removed very quickly, but yeah, that happens all the time. So.
Like, what's the point of somebody creating a package that very obviously, if you showed some names that were very obviously weird names, why would anyone ever know? Like, why bother creating the first?
So these specific names many times are trying, especially when they're uploaded in a really big mass, are trying to pull you away from the real packages that are trying to be used. Also, sometimes you have one package that looks legit and the malicious one is hidden in a web of dependencies. These dependencies can have whatever name you want. Many different reasons. Exactly. Some of them have some sort of, they activate some sort of backdoor because a package that is dormant for a long time is calling something that has no name. But when you publish it, you don't want to hint anyone what it's related to, so you just give it a random name. Whatever you can imagine is probably true somewhere in some scenario. Awesome. Thank you very much. Go have your coffee. I'm still here. If anyone has questions or want to talk to me, I'm here. Thank you.